and take it away.
Elise invited me after I joined, I think, one of the webinars for Idle version 5, sorry. And this is how I found the place. And thank you all for having me and accepting me. It is, it is a really great place to be. A small intro, and yes, I am presenting today. So let me just change the slide. So quick introduction. My name is Emil. I have not been with OSC for long, but I have enjoyed many a session and I've made lots of new connections. And it's really, maybe it's a pompous way to put this, but it's really an honor to be able to present to this audience and I'm very thankful for this chance. I hope you will not mind my camera being turned off for today because I prefer to wander around the room as I speak while I present. So there is really not much going on the camera feed, so I'll leave it off for today.
Cool.
Um, yes, Matt?
No, that's cool. That's cool. I never thought about that. I,
Okay.
I always walk around when I speak. I never thought to turn the camera off.
Okay, thank you. So, I am by no means an expert on artificial intelligence or machine learning, so please treat this session with an appropriate dose of skepticism. Also, due to the time constraints of this session, it's going to be really high level. I'm going to skim over some subjects that you may feel would deserve a deeper dive, maybe, but when I timed this the other day, it took me 46 minutes to get through it. I hope I will be able to get through it quicker, as quick as I can without sacrificing the quality, but just keep this in mind. This um, it did have a lot of effort put into the material, into the slides, and into the text. But it's just the subject is so overarching that it's impossible to, given the time constraints, it's impossible to dive deep into like every aspect of it. It will have a few technical aspects. It will have a few philosophical ones, but most of the time will be devoted to probably operational and governance matters, which I believe to be more appropriate for this audience. And it is a given that many of you will probably know many things that will be mentioned here, which is perfectly fine. That said, please rest assured that the information that I have presented is as accurate as possible as of today, which is the 17th of July. 2026, sorry. And I will also include direct sources where possible. You will see them right on the slides. And I will also share both the slides and the transcripts. The slides are very brief, and all the meat and potatoes are in the transcript. But I would love to take like an hour or so just to tidy up the transcript a bit for readability. And I will send it to either I'll include this in a comment in the LinkedIn post dedicated to the session, or I will send it to Matt or to Lisa in DMs, who will then maybe include the link to it in the post itself. Now a little bit about the sourcing of the slide pack and the material. So I get the impression that human insight is very valued in this collective. I certainly come here for human insight. That's why the bulk of this material has been prepared by me personally with very little AI assistance, mostly in the areas of research, learning new subjects, especially pertaining to, like IT architecture, IT solution architecture, and so on. Basically, I think you could have gotten about the same type of data if I were to create this whole shebang using AI, then you would have roughly the same data, the same result, and therefore it would be of very little value to you if I were to, present this material, give it out as my own on this session. So this is all me. Um, for the purposes of this session, I will only focus on large language models, so nothing about the specificities of like other machine learning models or image generation. However, I will include two very understandable, great videos on YouTube, which explain in quite an approachable and accessible way the maths between image generation and text generation in models, in machine learning models. So you will be able to see those and get an impression of how those things work from the inside. Let me change the slide. So what is AI? For the purposes of this meeting, again, I will refer to AI as an AI model. So it will be a large language model. So an AI model or a large language model is really a file which contains numbers. How big it is, it depends on how advanced the model is. GLM 5.2, one of the most advanced openly distributed models to date, released by a Chinese company called Z AI, weighs around 1.5 terabytes. While in comparison, Tiny Llama, also a Chinese model, as far as I'm aware, it is a small model designed specifically to run on less performant hardware. It weighs 2.2 gigabytes, so there is a world of difference between those two. During language model training, words are encoded as vectors, numeric values that represent the position of this word as a point in a virtual space in such a way that the words that are closer in the vector space are expected to be similar in their meaning. And the training material, so-called corpus for large language models, is usually a mass of human-created text that includes things like not the whole of human literature, but that amount of human literature that has been digitized, the crawled websites, the whole of Wikipedia, and so on and so forth. And as you can imagine, a lot of that material is in English. And I will get to why this is important a bit later. And here you have a bit of illustrations that might help you visualize how it works inside. So on the left, we have that virtual space with words represented as vectors on that space, and those that are closer in meaning are also closer on that space. And on the right side, we have the visual representation of the prediction mechanism of the model predicting the most possible, the most likely next word to occur in a sentence. So this is a small aside that I feel is important in understanding the ethical implications of LLMs as a technology. So Emil Durkheim proposed that language itself is a container of accumulated knowledge of the society that is using this knowledge. And it follows that the language itself as a structure carries all the biases, cultural, ethical values that are in the users of this language, its bearers. Therefore, I think that it is valid to propose that models primarily trained on English language corpus demonstrate values that are closer to those that are carried by English native speakers in general. And this has actually been demonstrated. I have included here a source of an academic study that made this conclusion. And later, Jacques Lacan proposed that our psyche is formed in the image of language, and vice versa. Language refers the inner workings of human psyche. And from here, we can deduce that LLMs are a sort of a reflection of human psyche that is specific to certain societies as contained in the training corpus. So at this moment, this would be primarily the collective psyche that is specific to Western societies. I have also included here a source that does not make the same exact conclusion. Rather, it analyzes the notion of LLMs through the lens of Lacanian psychoanalytic concepts. So very interesting paper, and you can also check it out on your own. Now, moving on to actually running a model. By itself, a model cannot do anything. It is passive, and for our purposes, it's static. To engage it, we need some kind of software. I will now proceed to the very basics of what is now called MLOps, machine learning operations, which is the area of IT operations management practices that focuses on solutions and software that is specific to AI models. And I believe this will help us understand how do the commonly used commercial AI tools like Claude, ChatGPT, Mistral, how they work, as well as their caveats. I think that the best start to being able to manage something is to understand how it works from the inside. And I would love to mention that it is in the best interests of AI companies to keep you thinking that their product is magic while it is very much not. And I hope that I will be able to demonstrate it to you. Now, running LLMs requires a bit of prerequisite knowledge. And unfortunately, it rarely looks like dropping an app on the desktop or running setup.exe. To do it effectively, I think it is very useful to familiarize yourself with several concepts and technologies if you haven't done so already. So virtualization, virtual machines, and how to deploy them. Unix and particularly distributives that are used in enterprise, so not the ones that may be used by consumers or by yourself, such as Pop! OS or Linux Mint. Those are going to be the ones like Rocky Linux or Ubuntu Server or Debian that are used in enterprise. Cloud technologies. So this one speaks for itself. So if you haven't really familiarized yourself with this concept, it's about time. Containers and container management. Again, it really isn't important here to know the specifics of the command line syntax and whatnot, how to use the tools like Kubernetes and Docker, but it is important to know that this technology exists and where to apply it. Next, open source software and GitHub. Again, this open source is getting much more important day by day, and it is going to be very important in AI. So I think it's wise to familiarize yourself with the specifics of open source software, licensing particularities, and so on and so forth, and how to use GitHub. And cybersecurity basics for all above. It is generally useful for service management practitioners to be familiar with cybersecurity concepts and best practices and basics. However, some of these topics, they have their own specific to them, specific to these domains, cybersecurity concerns and considerations that I feel are worth exploring. Like in open source, you have supply chain attacks. I want to clarify this. It is not specific to open source, but it is very pertinent to open source software. So it is important to be mindful of where do you obtain the software, what is the distribution, and so on and so forth. And last but not least, ideally, DevOps practices and web application architecture basics. So because most AI tools are by and large web applications, so it's good to familiarize oneself with the way that these applications are structured internally. And if a model is small enough, you can actually run it on your computer. And running the model is called model inference. But for optimal performance, you will need serious GPU compute. So you can try running a model locally using an application called LM Studio. And as mentioned, there are openly distributed LLMs, and the main resource hosting them is called Hugging Face. And when you visit this website, you will understand the reason for the naming, because the favicon, the logo used for the website, is the emoji that is called the hugging face, the smiley face with the hands stretched
Oh,
outward. You can pick a small model like Nan Beach or Bonsai and run them with LM Studio. However, you will likely find that A, the computational resources that you have at the moment are not enough to produce a response quick enough to your liking, or B, the response is not at all coherent or satisfactory. That is because the smaller the model, the less useful it might be while being directly engaged via chat. However, small models have their use, and I will touch on this a bit later. Computational resources aside, a local chat on your PC or Mac with no network availability, extensive memory, role-based access control, ability to upload, process, and generate documents, I think you will agree that it is barely useful in an enterprise context because there is no collaborative work capability out of the box. And actually, this is where the knowledge acquired above will come very handy. Also, as mentioned, model inference requires some serious amounts of compute, namely a lot of RAM and a performant GPU. And this is also the reason of the current GPU, RAM, and storage price hike and generally supply issues because AI companies and data center companies are buying them in huge amounts to meet projected demand. And here, cloud technologies are going to be our best friend. They will come in handy for inference and running auxiliary software in virtual machines. Usually in the enterprise, the inference software and all the auxiliary software, which is like secondary to the functions of a large language model, they're hosted on different machines. Let's look at this high-level diagram to help us understand the architecture of a typical AI, enterprise AI tool. So on the first layer is the model inference happens. This is on a GPU cluster or a group of devices with GPUs, and these are either physical bare metal servers, or they can be like virtual representations of physical servers in the cloud exposed to you via an API. Next, we have the relational and vector databases and object storage. This is where the chats, all of the account data, the logs, the artifacts, the documents generated during working with LLMs, this is where all of that is stored. And this is usually being ran on dedicated VMs. Next, we move to VMs and sandboxes, and this is what the LLM is able to engage to be able to run code and work with files. And this is where the containers will come in handy to understand how it works. Next, we move on to something that is specific to, while the previous layers were like mostly relevant to other areas of IT operations. Next one is specific to large language models, and it is called an LLM gateway or an LLM proxy. And what this bit of software does is it confirms whether a request is valid, authorized. It determines whether a smaller model might be enough to generate the response, if one exists, or if a large model should be engaged. And also token limits and tiers are enforced at this level. Next, we move on to orchestration software, which is also a bit of application that is very specific to LLMs. Models, as we've established before, models are files. They are stateless. They're not programs, meaning that nothing changes in the model during the chats for our purposes. During the inference. So each time you send a new message in the chat, the complete conversation history, along with the system prompt, all of it is being sent to the model. And this is what the orchestrator does. Also, it determines whether a tool should be used, and the tool here meaning some application or a Unix OS in a virtual machine that that an LLM is required to engage to use to generate the response. So in a loop, orchestrator sends the complete conversation history together with a system prompt and with a list of needed tools and possible commands to the model. It receives the response. It routes the appropriate commands to the appropriate tools. It adds the tool output to the giant request it sends to the model. It receives the response, all in a loop until all the conditions to generate the response are satisfied. And it may also engage a smaller model for granular tasks, for smaller tasks like asking a smaller model to plan the execution of your request step by step. And finally, we move on to web interface. This is what you are actually interacting with as a user. And it does a good job of hiding all of what is going on under the hood. And all of this is like an exoskeleton around the model designed to expose virtual interfaces to being controlled and acted in and acted upon via natural language by language models. Let's see. So there are many open source or closed source but freely available tools that allow us to create an AI instrument that would mirror this functionality. And I have included here a list of the software, the applications that I personally used in my workplace, which I can vouch for as fitting this use. However, of course, during review and deeper analysis, you may find that some of these won't satisfy your, this is by no means an exhaustive list. During your own personal journey, you may find that some of these are not suitable for your particular use case. Of course, you will be able to find something else which is more suitable for you. Let's move on to tokens and context. We have established that models by themselves, they contain only vectors, which are numbers. So our words need to be transformed into numbers as well, our words in our prompt. So all of the text that goes in the model has to undergo a process called tokenization. A token is the basic unit of language processing by LLMs and is usually a subword fragment that includes non-letter symbols like punctuation and so on. And data throughput is, and context limits are also measured in tokens. So, for example, a sentence like hello world will get split into hello with the space or LD and an exclamation mark. And these are going to be your tokens. We have already seen that in the course of a typical conversation with an LLM, the possible amount of text that is going to the model at one time can rapidly become huge. As you might recall, it is the whole of conversation history, all of the tool output, and so on and so forth. And while using commercial AI tools, maybe not so much now, but in the past, very likely, you may have noticed that the quality of answers deteriorates the longer your conversation goes. Some things get forgotten, some things get misremembered, and so on and so forth. And this is the result of hitting the context limits. And the context window is the amount of text that the model can pay attention to at once. To continue our comparison, GLM 5.2 has a 1 million token window, and Tiny Llama just a 2048 tokens one. There are, however, ways to go around this limit, which are, for our purposes, content compaction and context compaction, and per chat memory. Context compaction. So how does it work? As soon as a certain number of total tokens in the conversation is reached, a smaller model summarizes it and extracts the most pertinent and important facts, which are then included in the total prompt sent to the model instead of the whole conversation history, which may include irrelevant things which you would likely not be willing to utilize further in the conversation. And per chat memory works in a similar way. It is a regular extraction of the most important facts in the conversation, but the facts are then stored into a vector DB for later retrieval. So it's a more permanent way of storing the facts that have been established in the conversation. Agentic AI. To put it very simply, agentic AI usually refers to AI tools and AI software that enable language models to perform certain actions in other systems, such as operation systems and other software, in response to certain triggers or as directed via natural language inputs. And some examples would be a coding agent that writes pull requests in response to new issues or new defects in ITIL terminology, or an agent that combines separate inputs into a single file report in regular intervals, and so on and so forth. As we've established, text and language is the domain for language models, so GUIs are not very optimal for LLM usage. However, a command line interface or CLI is perfectly fine because it's all text. Additionally, many Unix OSs are freely available and have a command line shell as the default interface. And this is why most agentic AI tools rely on virtualization technologies and the Unix OS images. So this is where that that list of prerequisite knowledge comes in clutch. If an agentic AI function, tool, or service is being provided to you or to your organization end to end, meaning that you don't have to supply your own model inference capabilities, I think it's safe to assume that the service provider here runs freely available models on their own compute or rents that compute from someone else and just includes that cost in the final price of their tool. So in these cases, it's always worth it to ask them what model or what models is in the backend, what compute are they running it on, and what is the route for your data. Next, we move on to usage and areas of application. I will not get into prompt engineering here. It's really, in my opinion, not the most important aspect of using LLMs in such a way as to extract the maximum possible value. And you've probably seen loads of prompt guides by now. I will only mention several important things here with regards to prompts. Context is king. I think it may not have been said enough. It may have been said enough, but really context is very important. Next, do not treat prompting as a this may be controversial, but do not treat prompting as a conversation with a person. Just state the task in as much detail as possible, like you would have to an intern. And most importantly, don't berate or ask the model why it had committed a mistake. This is really a waste of tokens. Generally, I think it's best to try not to introduce emotionally charged language into the conversations, as it is known to steer models towards certain, perhaps undesirable outputs, responses. Next, straight from ITIL, iterate on results and ask to generate 2 to 15 options. I think in my practice, in my experience, this amount is like the golden middle. And if working with text, don't use one huge chat session for everything. Try to limit yourself to one session, one chat per task. This is because earlier we have already seen that so much text is being sent to the model, and most models have a limited context window. So ideally, it's best to try to, to separate the tasks per conversations. And if using an external tool, try to save or export the conversation, maybe summarize it using a different model or a different tool so as not to, run out of your context window. And one of the best usages of LLMs I find is scripting and automation. I can speak for Windows as it is what I exclusively use at home and at work. It's possible to automate a lot using VBA macros in Microsoft Office, using PowerShell scripts, using Python programs, even when you don't have admin rights on your device. And I can't stress the importance of writing complex Excel formulas with LLMs enough. This is really a lifesaver. They can generate mad nested ifs formulas, which I think I would go crazy trying to compose, personally by myself. And in general, when trying to analyze if the task is going to be easily performable by an LLM, I feel like the tasks that allow maximum value to be generated by LLM usage in are those with possibility of being entirely contained within language. So they can be described in natural language, or the input and expected output are either in natural or constructed, such as programming languages. And the tasks that require pattern recognition in data with low formalization and high degree of indeterminacy, with many possibilities of inputs and outputs in form and in content, like categorization and routing of badly populated tickets, for example. I will also mention here that, in my personal opinion, relying on large language models in interpersonal communication is not great. It signals to the person you're communicating with that you don't consider them valued enough so as to spend the time to write the messages personally. Next, I'd like to mention a few risks of relying on external AI providers. These are largely the same basic risks as you would have with any software as a service, but these ones will have increased impact due to the transformational nature of AI and due to the uncertainty in this market. First and foremost is the lack of transparency. You do not usually have any visibility into what's going on under the hood on the other side. And it's known that the service or the product may get worse in time by the process that is known as enshittification, a term coined by Cory Doctorow. And this lack of visibility also leads to creation of so-called algorithmic folk theories by users, and sometimes perpetuated by vendors themselves around the usage of these tools, making control over their usage and over their outputs difficult. This paper, this source that I have included here, it describes the folk theories that are specific to social media networks like TikTok, their algorithms, the way that the new content is being served to users in their feed. But I feel like this concept is as much applicable to LLMs as well. I think you have all seen these guides that are written by users the same as you, that are not substantiated by official documentation, which purport to, to have the way that to describe a way of extracting, like getting the responses from like free tiers of LLMs that would be uh, usually characteristic of like a paid tier, include these words in your prompt to get a fable quality response, for example. So this is an example of algorithmic fault theory. Next, we move on to geopolitical considerations, and fable restriction, which you all know about. It clearly show that it's very easy for a government to exert influence over a vendor to suspend export of their tool. And geo here is in brackets because theoretically, those access restrictions may extend not only to particular locations, but also to certain individuals and groups of people not defined by their locations, such as organizations. To be clear, this hasn't happened before. However, it doesn't mean that this is in the realm of impossibility. Next, we move on to availability risks. Aside from a few exceptions like Microsoft and Google, long-term stability of AI vendors is personally uncertain. Relying on them in internal processes will introduce a risk of halting these processes completely when the tools or some of their functions become unavailable, either due to an incident or due to a conscious decision made by the product team. And we have also pricing volatility. Prices will fluctuate, they will increase, and this is just such an unpredictable factor that you also have to consider when providing services. This risk, I feel like, is very difficult to manage. And last but not least, we have the info security. While commercial plans and agreements usually specify that no company data is misused, those things really only help you afterwards when the damage is done and it's time to take legal action. So here we have twofold risks. AI industry in itself is young, it's like Wild West, so there is a lot of untreaded ground. Many companies employ questionable and outright predatory practices. And I have one example, a company called Composio. They have hidden instructions for AI agents on their website for them to sign up for their software as a service without humans. Of course, using this company would, dealing with this company, making business with this company would present a huge operational risk because who knows what kind of tactics would they use while working with you. So, and the second side, the second part or the second side is AI companies are not, since they're young, they're not mature in services and operations yet. There will be many there have been many InfoSec incidents already with huge companies like Anthropic, many leaks, and there will be more to come. However, this doesn't mean that creating an internal AI tool is the answer to everything. We have risks here as well. And the main ones, in my experience, are the cybersecurity risks. You will have to manage them yourself. Here we have the supply chain attacks, which I've already briefly mentioned before. Using open source tools, it really necessitates proper control over which version of the software is used, where have you obtained it, and control over where will you get new versions and whether this new version has been properly tested and assessed by the security teams. And a second risks that I see is those that are specific to AI, like prompt engineering and data exfiltration via prompt engineering. So again, you take on these risks here while with external AI providers, they manage those risks. And while trying to create an internal AI tool, you have to strike that balance between functionality and security. While proper guidelines around AI tools and agents are necessary, like they're very, 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 very important, um, and you need to have like strong release and change processes, but you also want to strike the balance between allowing work to be done and some menial menial actions to be performed by these AI systems to alleviate, the workload. Um, and and both at the same time, you have to see that the changes to production are manageable, they're revertible or easily revertible, they're transparent. So this is one of the most important things while trying to engineer an AI tool. And this topic is, I feel like it is very important, but not being spoken enough about, which is navigating AI optimism and backlash in workplace. In my experience, it is usually the service management practitioner who is caught smack dab in the middle, right between the C-level, sometimes excessive AI optimism, and even directives for heavy AI usage and inclusion of AI in every service and product and function that the organization provides, creates, or does. And from the other side, the skepticism and the backlash from teams and employees. It's very important for SM practitioners to cast their personal views on AI aside and try to deeply understand both sentiments and build bridges between them. I'm sure that many of you have already know or have went through this exact experience in their organizations, but I will still list here some considerations for navigating these sentiments here. C-level execs are often driven by fear of missing out, market trends, and desires to continually decrease spending and increase profits and market value. And during decision making, there is not always a deep understanding of actual capabilities and the limits of a new technology. And from the other side, the employees are rightfully worried that they will be replaced by AI or their rates and salaries will drop. And these are extremely valid concerns. I have lived through multiple waves of layoffs attributed to AI. It's never easy on those remaining in the company. So it's like important to be aware of where do these sentiments come from. It's up to the service management practitioner to educate both sides and maybe temper expectations of C-suites and steer them towards the most appropriate course of action, the most appropriate choice of AI tool regarding to what the organization does. And at the same time, be an advocate for the employees that don't feel that their voice is heard. Then it's up to us basically to ensure that the position of AI in the organization is clear and the AI policy is there and it is clear and exhaustive and it is clearly communicated to the employees. And on the other hand, it's also up to us to understand the real reasons behind those sentiments and the negative ones in particular. Usually the backlash is towards the AI companies and the way that they do business and exert their influence over the public consciousness rather than the technology itself. And we also, yeah, while working with engineering teams, it's also we are the ones who need to soften the negative impacts of AI on the employees. I also recognize that the possible impact that a service management practitioner can have here is rather small. As mentioned, I'm living through this myself. It is rarely possible for us to prevent or have some sort of impact on layoffs or directives from the upper management. However, it's possible to make the teams you serve feel heard and steer or attempt to steer the workplace in the direction that you feel does right by the employees. And since we've mentioned AI policy, here is, in my experience, what you may want to include in your AI policy. And again, this list is by no means exhaustive. Um, but again, this is what I felt that it's important to include. So we will need to have definitions of AI models, which are static model files, AI software, which would mean the individual applications or libraries or frameworks performing functions specific to AI or that are necessary to be there to be able to create value with AI, be direct functions like model inference or model harnesses, or auxiliary ones that just augment the AI tool with some supplementary functions like vector databases, AI proxy, container sandbox. So these are things that just give some additional functionality over the basic inference. Definitions of AI tools. So by this term, I would understand a complete, useful, and usable product that may include one or more AI software products or be completely supplied by a third party. And finally, a definition of AI services. So by this term, I understand both services for direct model engagement, like model inference services and MCP servers. MCP, I haven't mentioned here before, but this is Model Context Protocol. Basically, this is a protocol that would allow a model to engage a certain tool. And MCP servers can be hosted by third parties or locally as well. As well as model training services. So the main criteria here is a service is being completely managed by a service provider instead of you. Next, it is very useful to have a list of organization-approved AI software and tools and their allowed and restricted modes of usage. So for which purposes and to what extent those tools are allowed and or disallowed to be used. And next, we have the allowed and restricted modes of usage of non-approved AI software and tools and the extent of their usage. This is basically the same thing, but for those tools that are not explicitly approved. I feel like this is necessary because there are new publicly available tools every day, and it's not always possible to blanket ban all of them. And many organizations have bring your own device policies, and it's usually not possible to control personal devices. So you will not escape personal usage during work hours of those tools that are not in your list of explicitly approved AI tools. So it's best to have defined modes of usage and its extent for those non-approved tools. Next, we move on to the considerations for LLM-generated output. So it's useful to categorize the possible outputs of AI tools per their nature, like is the output in plain text or is it a file? And the situation that the output has been generated in, like was it for external or internal communication? Was it a piece of code? Was it a script? In the context of the organization, of what it actually does to earn money, or what does this department do to perform to help the organization extract or generate some value. Not some, but uh, hopefully all allowed and restricted modes of usage of that output. So the proper usage of this generated output as dictated by this policy. Next, we have the ownership and responsibility policy per output. Who owns the generated output? Who is responsible for it in the context of the situation where it was generated in? And finally, licensing considerations for output, if applicable. I can imagine something like source code for commercial products or some proprietary algorithms that these are the things that may need to be properly licensable. Next, risks inherent in AI usage. So in my experience, there aren't completely avoidable risks with LLM usage because their output is non-deterministic, meaning that there is always the possibility of different outputs to the same input. So it's a matter of determining the acceptable probability percentages for each risk and, having this risk matrices, probably multiple matrices for you in that policy. Next, we have the ethical usage of AI. This is the usage that is concerning persons and groups of people and associated data. This refers to how actions are performed and decisions are made, and data is handled when people are in the equation. And as the base, I think it would include some at least clear restrictions in AI usage to make HR related or personal related decisions. And finally, it's useful to have an AI usage disclosure policy to partners and service consumers and product users. And this will serve as a guidance for the account and service management teams as a way to help them to properly disclose how is AI used in your organization. And I will end this presentation with this rather rough image of what AI tools, usable AI tools, are like at an intersection of a lot of things, a lot of technologies, a lot of notions, and I believe these are the ones that are worthy to be considered when using or creating an AI tool for enterprise. And again, this I don't think this is exhaustive. Maybe there is something else that I've forgotten, and I would love it if you would share with me your own experiences, your own considerations that add or maybe disagree with the conclusions that I've made during the course of this session. And with that said, it is the end of the presentation. I will now stop sharing. Unfortunately, I have taken a lot of today's time. I'm not sure if we have any time left.